very short time until they eventually faded away. Now, a shooting star is that streak of light that appears in the night sky for a fraction of a second is a meteor. A meteor is a glowing trail of hot gas and vaporized debris left by a solid object heated by friction as it moves through the Earth's atmosphere, generally right at the upper fringes. If the solid body is still in space, it's called a meteoroid. So a meteoroid is an object in space. A meteor is one that's passing through our atmosphere. Now, as they go through the atmosphere, they might be moving at 20,000 miles an hour. So they're heated to thousands of degrees Kelvin. They convert their kinetic energy into heating the meteor and the air molecules. Meteoroids larger than a few centimeters are sometimes visible in daylight as fireballs. Hundreds of tons of meteoric material hit the Earth each day. The best time to observe meteors is from midnight to dawn. Now, most meteors are too small to reach the Earth's surface. However, some do, and we call those meteorites. So meteoroids are chunks of objects in space. Meteors are things passing through our atmosphere, and meteorites are what happens when they hit the ground. Now, it's not unlikely that you will get hit by a meteor. Here is a BBC article about a 14-year-old girl who was hit by a small meteor in 2002. I have other ones you can search for a 76-year-old woman who was hit in 2004, or the 14-year-old boy hit in 2009 in Germany. This young lady here was getting into the family car outside of her home in Great Britain and was hit by a stone that fell from the sky, and she noticed it was quite hot. She took it to a local university and they identified it as a meteorite. It's another article about the woman who was hanging out the wash, Pauline Agus, and she was hit by one in her left arm. Left an inch-long gash in her forearm. Or this 14-year-old who was hit by a 30,000-mile-per-hour space meteorite. Probably slowed down some as it was going through the atmosphere, but he saw a bright light heading straight towards him, and a red-hot pea-sized rock hit his hand, probably at a glancing blow, and caused a foot-wide crater in the ground. If it would have hit his hand straight on, or his head, it might not have been such a fun story. So these objects do strike the Earth, and we can pick them up and study them. And when we do, we can use the same radioactive age dating techniques as we've talked about before. And when we do, we see that most meteorites have the same age, about 4.6 billion years. And they are believed to date from the formation of the solar system. By studying their crystals, we hope to determine a lot about the early planets and how they were put together in the history of our solar system. For example, we can deduce that iron meteorites came from a fairly large object that got broken up, due to the specific ratios of impurities in many of the iron meteorites that land on Earth. A few meteorites came from the Moon, and we do have some that come from Mars, and we can tell by the ratio of different elements in them. The best place on Earth to find them is in Antarctica. Any rocks that we see on top of the ice in Antarctica we know had to have fallen from the sky. There are now serious attempts to devise ways of protecting the Earth from a major meteorite impact. And the Space Guard survey is one that's being studied right now that proposes a major program of telescope surveys. This picture off to the side is an artist's conception. This is an actual picture. You would have heard about this, of a fairly large asteroid striking the surface of the Earth. If one this size, say the size of the United States, actually hit, this wave of debris material could be several hundred miles high and would move at the speed of sound around the Earth. So we don't want this to happen. We want to be able to determine if something's coming at us, maybe be able to do something about it before it actually does. But it happens. Every few thousand years, Earth is hit by a huge meteoroid, a body tens of meters or more in size. A typical 100-kilogram meteoroid has the kinetic energy equivalent of 100 tons of dynamite, which would make a crater 30 meters across, or 100 feet. A 10-meter meteoroid has the explosive power of a thermonuclear bomb and would leave a kilometer-wide crater in the ground. Large meteorites have been hitting the Earth for a long time, and they can cause disasters. So, for example, the Barringer crater in Arizona that we've seen before formed about 50,000 years ago, and this was due to a meteorite the size of a house. Again, you can see the 4-lane road coming into this to tell you how big something the size of a house hitting us at 30,000 miles per hour, what kind of damage it would do. There was a mysterious explosion in Siberia in about 1908 that might have been due to a small comet exploding in the atmosphere. Essentially, this large region of mostly uninhabited area had an entire forest that was, all the limbs were stripped off the trees, and most of the trees themselves were knocked over to the side. Of course, hopefully all of you have heard of this large explosion in Russia in 2012, where 1,100 people were injured, mostly by the exploding glass that they were looking out the windows, and as the shock wave hit, caused the glass to shatter, and lots of eye and facial injuries. It was visible as a fireball as it went across the sky in the day. They found actually small chunks of it. Here are pictures at a school of windows that were blown out, and you can see a dust cloud in the background as it hit a factory in Russia. Now there's other meteor craters that exist. In Quebec, there's a ring-shaped lake, and this is the result of a meteorite impact that struck. Any circular formation that we see on the Earth is probably caused by a meteor crater. Or in Hudson Bay, we see this vast circular arc here. That's in the islands in the middle. That's due to a object hitting here and creating a crater. And remember, in the middle of the crater, there's a peak. That's these islands here. Or there's a basin in Central Europe that's about 300 kilometers around that's due to a meteor impact. Of course, about 65 million years ago, at the end of the Cretaceous period, an asteroid or comet hit the Earth, exterminating the dinosaurs and many other life forms. Now, evidence for an extraterrestrial cause of the extinction is the high abundance of what's a rare element, iridium, that's in the sediments all around the world at about the same time. And the amount of iridium suggests about a 10-kilometer wide asteroid that hit the Earth. A 10-kilometer asteroid produced the explosion equivalent of several billion nuclear bombs. Now, most of that energy is, some of the energy is going through the atmosphere as it heats up, but the explosion will be quite spectacular. Initial destruction by high temperatures, the blast, and acid rain would have followed by months of darkness and intense cold as the sun's light is completely blotted out by clouds and dust. Now, further evidence of the impact is a layer of soot, tiny quartz pellets, and a circular depression in the Yucatan region of Mexico. So the question we might ask is, will another strike occur? There's actually a relationship between the size of an object and the probability of a collision. Now, every year we get something that's about 20 kilotons of energy. Now, most of that is expended in the atmosphere as it goes through and creates a fireball and burns up, but sometimes they hit. Tunguska in Siberia, that's about a once every 1,000 years event. The one that we just had, it was actually pretty close to that, and so maybe it's at the once in a century, since this was in 1900 and this was in 2012. Every million years or so, the Earth has had what they call a global catastrophe threshold object that strikes it. So I want to go through now what different impact diameters do when they hit the Earth. So let's say it's less than 50 meters in diameter. It's about a 10 megaton yield. We get those about once a year. Even though they're 50 meters or half a football field in diameter, most of those don't reach the surface. They come in very fast and they burn up in the atmosphere. Our atmosphere actually protects us from quite a lot. About every 1,000 years we get a 75 meter impact diameter, which yields somewhere between 10 and 100 megatons of energy. Now, if it was iron, it's going to make craters like meteor crater. If it's made out of stone, it'll produce airbursts like Tunguska. A land impact could destroy the area the size of a city. At 160 meters around, we get about 100 to 1,000 megatons of energy. We get one of those about every 5,000 years, and iron and stone hit grounds. Icy ones, so comets produce airbursts. And a land impact could destroy the area of a large urban area like New York or Tokyo. At 350 meters across, we get maybe 1,000 to 10,000 megatons of energy released. We get one of those about every 15,000. Land impacts could destroy the area of a small state, say Connecticut. Ocean impacts actually produce mild tidal waves. At 700 meters in diameter, get 10,000 to maybe 100,000 megatons of energy released about every 63,000 years. A land impact destroy an area the size of a moderate state, say Virginia. And ocean impacts make really big waves. And finally, an impactor of about 1,700 meters, or a mile in diameter, you can get up to 1 million megatons of energy. Get one of those every 250,000 years. Land impacts actually would raise dust that would have global implications and could destroy the area of a large state like California or maybe France. So that's all that we want to talk about on small planetary bodies.